Hi, my name is Taylor Ashley, and today I will be presenting the melanocortin 1 receptor, also known as MC1R, and my mutation is the arginine number 67, replaced by cytosine R67C in the conditions of beach mouse of fur colorations. So, what is the MC1R gene? The MC1R gene is a protein to make normal pigmentation, and in that production, it's called melanin. Now, the melanin is a substance that that gives your hair, your skin, and your eyes their color. And to get more technical, the MC1R is the chromosome 16 in mammals, and in the codon portions of the gene, 951 nucleotides long in the codon for 317 amino acids. The same process occurs in the mice is for hair is also in for skin. So where you could typically find this? In this case, animal organisms, mostly mammals like mice. Um, we're mostly going to be focusing on the hair follicles so we can figure out their fur coloration process. Um, in their hair follicles, there's a site called melanocytes that specializes in their cells that makes the pigment of melanin. There are two types of pigments that is produced: eomelanin, which is produces dark hair color, and pheomelanin, which is produces the reddish hair color. So when we get more down into the normal function, the transcription is cytosine, and the corresponding codon is arginine. Now, arginine is a lot more active, is much larger, 50% larger molecular weight wise, and according to the research, all the nucleotides are identical except in position 199, which is arginine. Arginine is very hydrophilic, very polar, and it has a positive charge. So it attracts the negative and repels the positive. So in the actual hair follicle, the MC1R protein is transcribed into a protein and moved into a cell as a transmembrane protein. It will be used to detect something going on outside of the cell and transmit a signal inside the cell. On the outside of the cell, it will be placed in an extracellular space. If you get in contact with the melanocyte stimulating hormone, also known as MSH, they will bind together, causing the MC1R to change shape. So after it changes shape, it can interact more with the molecules inside the cell. And once they are able to interact, the reactions react quicker, and it also stimulates to produce the protein with the others to make that color, to fur colorize, which is the melanin. Now, when it comes to the mutation, um, cytosine is very much hydrophobic, non-polar. It's a neutral charge. Basically, it doesn't attract or repel to anything, nor attract to water. Some of them do have sulfur, and it can connect to a sulfur and amino acid and make a disulfide bond. And it helps give the protein its shape and function. So in the hair follicles for cytosine, basically thymine is the transcription and the corresponding codon is the cytosine. So in the hair follicles, if it binds with an MSH, the reactions won't go off the same as it did for arginine. So therefore, that's what causes the lighter color, and it produces less melanin. So that's how the fur mice got a lighter color compared to the fur mice having a darker color. So I will be showing you two different diagrams of the arginine and basically the cytosine. So this one is arginine. As you can see, this is where it starts and where it finishes. Basically, this represents the nucleotides, the sequence, and I put a little dot right there to represent as position 199 for the corresponding of arginine. And basically, what I'm trying to show you here is that since it has arginine right here, it's going to continue with the corresponding sequence for arginine to produce that dark fur color of melanin. And that's when it gives off that strong reaction, and it causes it to go dark. I know it doesn't show that much on here. It just shows the nucleotides but I just wanted to show you the nucleotide sequence of how it starts to finish with arginine right there, and basically how it's giving off a strong reaction, and it's going to produce the dark pigment in the beach fur color mysis. Now, in the other one, I have the cytosine. You can't really tell, but I mixed up the gold and the silver to show that it's producing less melanin. So this is the start and to finish, position 199 of cytosine as the corresponding. And basically, according to the research, once this produced, it's gonna give off a different response, basically. So the reaction won't be the same due to this being cytosine and having not being as active as it is with arginine. Same thing with this one, the basically I'm just showing you the nucleotide sequence and showing you that it's going to produce less melanin, which is just going to give it its lighter color. Nothing different or nothing too crazy. Like I said earlier, out of 951 nucleotides sequence, only position 199 is different. Everything else is still the same. It's just different amount of melanin that is produced out at the end. But yeah, that is pretty much it. Thank you for listening, and thank you for taking the time out to hear my project. You have a good one.